Okay, so this is what I call the number pairs: 1 and 8, 2 and 7, 4 and 5, 3 and 6. In case you're wondering what happened to the 0 and the 9, at midnight it's also expressed as 00-00 or 2400 hours. And so the 9 and the 0 are interoperable, and they themselves are paired. So we have 5 number pairs: 1 and 8, 2 and 7, 4 and 5, 3 and 6, and 0 and 9. Once I saw how using this simple mod 9 lens gave me some insight into how certain numbers are related to certain others, I put this mod 9 lens over all of the important number sequences that have to do with physics, chemistry, and biology. Packing of space and all the possible integer sequences. And I found something incredibly interesting. So we're starting with the cellular mitosis sequence, which is the simplest number sequence. You simply double the previous number. So it starts with a 1, becomes a 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, etc., etc. Now, when you look at that sequence of numbers and cast the mod 9 lens over it to find what time it is on a 9-hour clock, you see that it repeats every 6 digits. It goes 1, 2, 4, 8, and then the 16 becomes a 7, the 32 becomes a 5, and so this repeating sequence 1, 2, 4, 8, 7, 5 goes on indefinitely. And then I noticed that if you split the 6-digit sequence and place the first half above the second half, well, you can see the number pairs in what I call a 2-dimensional numerical symmetry. So you can see the 1 above the 8, the 2 above the 7, the 4 above the 5, just like we saw in the multiplication tables. Now further, instead of writing them in 3 columns, we write them in 2 columns, and we go 1, 2, 4, 8, 7, 5. If again we read vertically downwards, we see what I call a 3-dimensional numerical symmetry, which shows how these numbers work in very specific groups: 1, 4, 7, 2, 5, 8, and the last one will be 3, 6, 0 or 9. So in summary, we have 5 number pairs: 1, 8, 2, 7, 4, 5, 3, 6, and 0, 9. And we have 3 number groups: 1, 4, 7, 2, 5, 8, and 3, 6, 9. So having seen this in the doubling sequence, the key thing to understand about this doubling sequence is that it's essential to biology. It's essentially the process of cell division that allows humans to grow and for cells to repair themselves. So this is very deeply baked into who and what we are and how we operate. So the next most important integer sequence is something called the Fibonacci sequence. And this was discovered back in the early 13th century by a chap called Fibonacci, and actually it dates back much earlier. But he was the one whose name has been attributed to this particular sequence. And to get this sequence, you simply add the previous 2 terms to get the next term. So you start with a 0 and a 1. 0 plus 1 is 1, so it goes 1, 1, 2, which is 1 plus 1. And it's 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 8 is 13. And the beautiful thing about this particular sequence is that it's deeply embedded in the way that everything grows. Everything that lives is subject to this particular sequence in terms of its growth. Now, the interesting thing about this sequence, well, there's lots of interesting things about this sequence, but as you get progressively higher up the terms of the sequence, in order to get from one number or one term to the next term, we multiply by something called the golden mean, which is a value of 1.618. And this number is also essential to aesthetic beauty. So the closer you are to the average, the more beautiful you are. So now in looking at this very important integer sequence, the Fibonacci sequence, and looking through the mod 9 lens, what I discovered was that there is a 24-digit repeating sequence mod 9. And so we'd seen a 6-digit repeating sequence in cellular mitosis, but here in Fibonacci, the length of the repeating sequence is 24. And here we see it, and it repeats forever and ever. And I was absolutely staggered by that. So you've got a regularization of all these increasingly enormously massive numbers that don't seem to have any rhyme or reason, and yet in their essence, they are perfectly rhythmical. And interestingly, so I split, in the same way as I split the 6-digit recurring sequence in cellular mitosis, I split the Fibonacci sequence in two. And lo and behold, again, we see perfectly the number pairs, 1, 8, 1, 8, 2, 7, 3, 6, 5, 4, etc., etc. Unbelievable. Then we look at it and make it, because it's 24, we can make it 3 strings of 8. So there they are, the first 8, the second 8 underneath, and the third 8 underneath that. And lo and behold, we see the number groups, 174, 1s, 258, 369, 258, 8s. So that the 1s and the 8s are balanced, and the 471, 369. So again, confirming the existence of this 2-dimensional numerical symmetry and a 3-dimensional numerical symmetry. And in fact, this one has a further system of symmetry, and that is a 6-fold symmetry, where we see, in the first column, we see 1, 2, 4, 8, 7, 5 from the cellular mitosis sequence. Then the 1 and 8 number pairs. Then 1, 2, 4, 8, 7, 5 again. And then the final column, 3, 3, 9, 6, 9, 6, 6, 9, which is just that family number group. So then, without wanting to bore you, I applied this to absolutely every single kind of integer sequence you can think of, including all the geometric shapes, the platonic solids, you name it. Had a look at them all, and every single one, without exception, produced a repeating sequence using the mod 9 lens, and which all displayed the exact workings of the number pairs and the number groups in their respective 2- and 3-dimensional numerical symmetries. So this is something, this particular system, and the numbers forming in pairs and groups, is completely ubiquitous to everything in nature, including, the packing of space, and everything you can think of has this regularity to it if we apply the mod 9 lens to it. So what I'm saying here is that decimal system of number is actually essential to the workings, the mechanics of the universe.